Hello everyone. Today we'll learn about a problem that we need to solve with the help of stacks. This is the continuation, this is the third part of the stacks videos that I've been making in the Helm of Science channel. I've made the stacks theory and I've also made the stacks implementation in Java. These two are the uh, two videos that you must watch before getting into the problem if you do not have a basic understanding of stack. If you want to know how this problem is solved with the stack and you already know the theory of the stack, you already know how to implement your own stack, then you are in the correct place. But if you do not know what stacks are and how stacks work, then go through the last two videos on the Helm of Science channel and then come to this video. Now we'll start with the problem statement today. The problem statement is that a bracket is considered to be one of the following characters. Obviously, the first bracket, the second bracket, and the third bracket. Now, the two brackets are considered to be matched pair if any opening bracket occurs to the left of the closing bracket. That means if the first bracket opens, then after whatever bracket there is within that bracket, it should also close, and this closing bracket should be on the right side of the opening bracket, or the opening bracket should be on the left side of the closing bracket. There are three types of matched pairs of brackets. Obviously, a matching pair of brackets is not balanced if the set of bracket it encloses are not matched. For example, in this case, these two brackets are the brackets that this first bracket encloses, and therefore these brackets are matched pairs because the opening of these brackets are on the left of the closing bracket, and therefore this bracket is a correct or a matching pair. Now, by this logic, we say a sequence of brackets is balanced if the following conditions are met. It contains no unmatched brackets. So in this case, if any of these brackets was unmatched, let's say if this was like this, sorry, if this was like this, then it is an unmatched pair because this bracket is enclosed within the curly braces, but the bracket which is the closing bracket, the closing third bracket, or the closing square bracket is outside of this curly braces, and therefore it is an unmatched pair, and therefore the whole bracket is an unmatched pair. The subset of the brackets enclosed within the confines of the matched pair is also a matched pair, and in this case this does not play a part. Okay, now we'll go to the problem statement. The main statement is that if we have a strings of brackets, determine whether each sequence of brackets is balanced, and if a string is balanced, then return yes, otherwise no. So in this case, let me explain. If we have a set of brackets like this, this is a balanced bracket because this is the first bracket which ends at the last. The second bracket opens here, closes here, and this contains a matched pair of square braces, and therefore this is a matched pair, and therefore this is also a matched pair, and this is a balanced bracket. So this is right. But in some case, if it is like this, then there are lots of mistakes in this. The first thing is this first bracket opens here, but there are two first brackets closing. That means that this closing bracket here, this one, is either the closing bracket of this, or it is an isolated closing bracket, which is wrong. Here the second bracket opens outside of the third bracket, but it closes inside of it, and then there is another second bracket. So there are a lot of mismatches in this string also. and this also does not contain a matched pair, it just contains one bracket, so this is also a wrong pair, and therefore these are the mistakes that it has. So what we'll use is we'll use a stack like this, and let's say we have uh, a string like this. So first what we'll do is whenever we get an opening bracket like these, we will put that into the stack one by one. So we'll get to the first bracket here, we'll put that in the stack. Then we get to the second bracket, we'll put that into a stack. We get to the third bracket, we put that also into the stack, and then we go to the fourth position, but here we have a closing bracket. Now whenever we reach a closing bracket, we have to see if the last bracket which was opened was the same bracket which is being closed. So in this case, it is the third bracket that is being closed. So we need to check if the last bracket which was opened was the third bracket or not. And in this case, we know that the peek method gives us the last element of the stack, the topmost element of the stack. And in this case, we have to find that. So we just peek and see if this is the third bracket. So we have reached the closing third bracket. We need to check that if we have opened the third bracket in the last instance. And in this case, yes, we have. So we completely forget about it and we pop this third bracket out of the stack. So now the stack is the second bracket and the first bracket, because at this position the second bracket is still open, it needs to be closed, and the first bracket that had opened first needs to be closed. Then it reaches the second bracket. When it reaches the second bracket, it again checks if the last bracket which was opened is the second bracket. And in this case, the last bracket in the stack is the second bracket, so it pops it out. And till now, nothing is wrong with this problem. Then it goes to the first bracket, and here the first bracket is opening. So we put that first bracket into the stack. Then we go to the closing first bracket, and so we check that the last bracket which was opened, was it the first bracket? And in this case it is. Therefore we pop that also, and there is no problem. Then you go to the last element, which is the closing first bracket. It checks if this bracket is the same as this, and it is. Therefore it pops that out too, and we are left with nothing in the stack. Now if in this case we had a third bracket here, or any bracket for that matter, then this would be a wrong string because the third bracket does not close anywhere. How will we know that? Basically, we have, if we go to this position, then we'll also enter the third bracket, and then after that we'll see that this is the last element, and we have traversed through the whole string, but we are left with one element in the stack. And if at the end of the string we are left with some element in the stack, that means that bracket has not been ended in the string, and therefore it is an unbalanced string. So in this case, and also if at the end in place of an opening bracket we had a closing bracket, this is also wrong because the opening third bracket does not exist. In that case, when it goes to this position, it will check if the last bracket which was opened in the string was the third bracket or not. But in this case, there is no bracket in the stack. The stack is completely empty, and therefore it will give an error, or it will say that the string is not balanced. This is the whole idea, and this is how we'll proceed with the stack in solving this problem. Now the next part of this video will be a coding part. I'll be coding in Java, and if you do not want to code in Java, then you're free to go through the video, understand the topic. I believe that if you know how I'm proceeding with the problem using the stack, you will be able to implement this problem in your own programming language using stack very easily. So go through the tutorial in Java only. But if you have Java, if you know Java, then implement this problem in Java. So the next part will be the coding part. Hello everyone, welcome back. And this is the coding part of the problem that we are solving. It is also called the balanced brackets or the balance parentheses problem. So here I have got the stack class that we have made. So here we have the stack.java, and this is the class that we made in the last video. There are some changes that I will point out. You can also see through your code that you have written and match the code and understand where the changes are. I'll tell you why. Because see, here is a char array, and in the original video I said it was an int array. Now the thing is, that was because I made an int stack, but in this case we are working with a string and we are working with characters. So we need to make the stack of characters and not of integers. So therefore we are using a char array. In the stack constructor, we are initializing array with a new char array of the length L. Then in the push method, we are taking a char value instead of an int value. Also, we are returning a char value from the pop method. Here you may see this hash I have given. So what is this hash? Basically, when the pop underflow, the pop reached a point where the stack underflowed, and then there was nothing in the stack to pop. At that point, we returned -999 because we thought that no one would ever give -999 in the stack. We will never require that number. But in a character stack, we cannot use -999 because that does not exist in a character. And so we are using a character which is not allowed in our program. So in this program, the input string will always have the first brackets, the second brackets, and the third brackets, and no other character is allowed. So we are using hash because the user may never use hashes. So the next part is in the peak also we are returning a char. Here also we are returning the hash so that we understand it's an underflow. You also may see that there were many system.out.println statements which was there for debugging, which said that this value has been pushed and this value has been has not been pushed because of stack overflow. I have omitted all those print statements because in our program I do not want those statements to interfere. I just want the straight answer if the brackets are balanced or not. Now we'll get into the balance brackets class. This might get a little complex because I will be telling you the easiest to understand explanation. I'll not be getting into a very professional way of solving the problem because that needs a little bit of knowledge about higher level data structures like hash maps and graphs. Now let us start with the problem. For this we are using this class. We have made this file called the balance brackets.java, and we are making a class within that balance brackets, and then we are making the public static void main. So I'm making the main method. Now inside that main method, I am going to start with taking the input. Now the first thing that we need to do is we need to import the scanner class, java.util.scanner, and inside the main method I am going to create the scanner object. So this is how we create the scanner object so that we can take an input from the user. Now we'll take the input from the user, but before that I'm going to print out something. I'm just going to say input the string. This will be the input statement. And after that, I'm going to take this input into the input variable. So I'm declaring a variable of string type and I'm taking the input into that. I'm using sc.next because if we use next line, then we have to deal with white spaces in between the string, and we do not want white spaces in the string. We just need the brackets only. So we are using next. Now starts the main part. See, first the thing is we need to create the stack, and for creating the stack we need to import the stack class from this file. Now this file is a public class. As you can see, it is a public class, and therefore if it is a public class, that means that we can import this class directly. So we just write stack equals new stack of size n. But in this case, let's just do this. Now here is a problem. In this case, we can write stack. This will automatically find this stack.java file. It will take this class and create an object of that class and store it into stack. But for that, we also need the size of the stack. As in this stack.java, in this constructor, we also need the size. And this is the size of the stack, the maximum size of the stack. But here we do not know how long the stack will be. But we know for sure that the stack will not exceed the length of the string. That means if, for example, we have a string like this, so this is a string of opening brackets only. If this is the string which is passed, then the stack is of the size of the string. That means all the opening brackets will get into the stack and there are no closing brackets, so it will not pop. So the maximum amount of space which is required for the stack is the length of the string. And so this is the worst case. And in this worst case, we need the length of the string to be the length of the stack. And so we'll use that only for the length of the stack here, because we do not know how long the stack may be. Okay, so we are using input.length to find the length of the string and put that as the length of the stack. Then we'll start with the main part. We'll iterate through all of the characters in the string. Just a minute. Let me write the for loop. Yeah, so this is the for loop. And in this for loop, I is the index at which we are checking for the characters. So we'll take that character, we'll say character current is equal to input dot char at I. What this will do is it will store the character at the ith position in the input string in the current variable. After that, we need to check if this current variable is actually an opening bracket or a closing bracket. Now, we can check this in multiple ways. The best way is we make a string of opening brackets and we use the index of function. We check current is greater than -1. So what this means is the index of function finds the index of this character in this string, and therefore if this current is an opening bracket, it will be in this string, and therefore this index of will return something which is greater than -1. It returns -1 only if it has not found that character. So here we are checking if the current character is within this string, then it is an opening brace, and so we need to stack dot push this value, right? That's it. The best part or the biggest part, the most difficult part of the program is if the current character is a closing bracket. So we have to check else if, the same way that we checked if it was an opening bracket, we have to check if it is a closing bracket. Let me see. The same thing. So the same thing that we did, we just checked if it was a closing bracket. Why did I check that it was a closing bracket? I could have used else here, because if it is not an opening bracket, it must be a closing bracket. But for a little exception that can occur is that when somebody enters something which is not a character, which is not a parenthesis, if the user enters some random character, then it should also handle that exception. And for that, I'm using the else statement. So if it is not an opening bracket and it is not also a closing bracket, that means it is an abrupt and a random character, then we'll just print that it is a wrong variable or a wrong input, and it will go on, it will move on. But after that, if it is a wrong input, then we should not check the other characters, because if it is a wrong input once, it is an unbalanced bracket there and then. So we just do a return from here. If we write return, that means it will just go out of the main method and it will not execute anything other than till this line. So after this line, if it encounters this return, it will just go out of the main method. It will not execute anything after this. So in the else if part, basically, if the current character is a closing bracket, what we need to do is we need to check if the last open bracket was the same as the closing bracket. So for that, let me take the last opened equal to stack dot peak, and stack dot peak returns the last last character in the stack. After that, we need to check if this last opened is not a hash. If it is not a hash, then we have to check if the last opened is the same as the closing bracket. But if it is a hash, we'll write the else statement, which means that if last opened is a hash, that means the stack is underflowed. We need to say no, because we have discussed that if at some point there is no opening bracket in the stack left, that means the bracket that we are closing does not have an opening parentheses, and therefore it is an unbalanced bracket. So we just say no and return. So after this, in the last opened is not equal to hash, then we have to check if the current is equal to a closing third bracket and last opened is not equal to the starting third bracket, then we print no and return. So just understand this. If the last opened is not a hash, that means the stack is not underflowed, then the last opened, that means the last opened needs to be an opening bracket. And so we are checking if the current is the third bracket closing and the last opened is not the third bracket opening, that means there is a mismatch. And if there is a mismatch, then we print no and return. That means nothing after this is going to execute. It has found one mismatch, and that is enough for the whole string to be unbalanced. So what we'll do is we'll copy this and we'll print after the else if. We'll change this to a second bracket, and we'll also print the same thing again. We'll change this to a first bracket. Why am I doing this? Basically, I want to know if the current is a closing third bracket, then the last open needs to be a third bracket, an opening third bracket. If it is not, then we print no. Otherwise, if the current is a second bracket and the last opened is not a second bracket, then there is a mismatch and we print no. If the current is a first bracket and the last opened is not a first bracket, that means there is a mismatch and we print no. If all of these conditions give false, that means that there is no mismatch, and therefore we are going to make that else statement here. In the else statement, just a minute, yeah. In the else statement, that means in the else, we mean that there has been no mismatch till now. That means the closing bracket, the current closing bracket, is matched with the last opened bracket. And then what we need to do is we need to pop one thing from the stack. That's it. So if we pop from the stack, the last opened bracket will go out of the stack. So after this, we need to go out of the for loop, and here it means we are out of the for loop. That means we have not terminated. That means we have not encountered any of these return statements till now. That means to the last character, we have not encountered any mismatch. But we also have to check one thing: if the stack is empty at this moment. Because if it is not empty, that means one or more of the brackets are still open, and we do not want that. So we also have to check if the stack is completely empty. So outside the for loop, we have to check if the stack dot top is equal to 0. As I've mentioned in the last video, the top will be 0 only when the stack is completely empty. So in this case, if the stack dot top is 0, that means that all of the brackets that were opened were closed in the string and no bracket is still open or still there in the stack. And so that means the string was balanced. So we can print yes. Or else, if there is some thing in the stack, that means there is some parentheses which has opened but not closed, then it is a unbalanced print line no. That's it. So this is the code for the balance parentheses. Again, this is not the best code that I can write, but this was the easiest code to understand the whole thing. Now let's run this program once and see if it is running properly. Yes. So in the input string, I'll input a correct string now. This is a correct string. First bracket open, second bracket open, second bracket close, first bracket close. It prints yes. So till now we are right. Then I'll give a wrong string. So here, as you can see, the first bracket opens, second bracket opens, the second bracket again opens and closes, but the second bracket which opened before that did not close. Let's see if this is correct. It says no. That means that we are doing it right. So let's check one more time. Says yes. So till now there is no error in this program, and it is working, and this is the solution that I have come up with. It's a very easy solution to understand. It is not the best solution that is there to this problem, but it is of course one of the solutions of this problem, because it solves the problem without errors, and that's what we want. So that's it for this video. This was a video on a problem that we solved with stack. Try to do this program on your own once, because you already know the problem statement. If you're using some other language like C++ or Python, try doing this program with the knowledge of stack that you have gained from the last video. Try doing this program on your own in the programming language of your choice. And please let me know in the comments if you are able to do the program in your language or not. Thank you very much.